All right, we can go ahead and get started, and I'll take care of some housekeeping here while other folks are joining us. So thanks again for coming to this exciting webinar. I'm Jen with the Micronaut Foundation, and I also have joining me from the Micronaut Foundation is Sergio and Graham. So thanks, guys. Welcome.
Hello, hello.
Hello.
So we are going to be getting into the details and learning about some new features that are coming up with the new release of Micronaut 4. So we're excited about that. We can't wait to hear all about it. And please do load up any questions you have in the Q&A session. And the guys will answer as many of those as we have time for. And we are recording this, so we do plan to post that as soon as we can following this webinar for on-demand viewing. I believe we can go ahead and get started now. I know you guys have a lot to cover, so Sergio, I will pass it off to you.
Thank you, Jen. So I have here two monitors, and I have the Q&A open and the chat, so please don't wait until the end. If you have any questions, write them down, and we can comment those while we talk. The agenda for today, I essentially wanted to give like a high-level overview of some of the most important changes in Micronaut 4, and having here Graham have the opportunity to talk with him about some of those. But if any of you have any questions about something that we don't have here in the slides, please don't hesitate to ask, and we will try to answer those. So let me share my screen and talk Micronaut. So let me see if I'm able to see my Q&A and the chat. Go, okay. So Micronaut 4. So we released yesterday milestone 5. We plan to release so the first question is, when are we going to release Micronaut 4? And the answer to that is July. So we released yesterday milestone 5. We plan to release the first release candidate next week, and then following, if we don't find any major bugs while you test the Micronaut 4 release, we will release the general availability version of the framework. So Micronaut 4 will be released within the next 2 weeks. Today, for example, we were like building all the Micronaut guides with Micronaut 4 to have them all updated in the release date. So that's the first thing. The second thing, thanks to the Micronaut sponsors, the Micronaut Foundation sponsors. So they sponsor both the development and the advocacy of the framework. And now I'm going to talk about several things that have changed in Micronaut 4. So Micronaut 3 was using Groovy 3. In Micronaut 4, we have a baseline of Groovy for Groovy 4. I think Groovy released yesterday or the day before Groovy 4.0.13, and we will be updating our internal bits to use that. We are actually, I think, building right now in 4.0.12. So if you were waiting for Groovy 4, that's coming in Micronaut 4. So that's exciting. One thing to know for Micronaut uses, if you are using GORM in combination with Micronaut, GORM still doesn't support Groovy 4. So we will support it once GORM supports Groovy 4, but that's not there yet. Another big thing is the upgrade to Kotlin 1.8. So Micronaut 3, we were like generating applications using Kotlin 1.7. So you were waiting for the next version of Kotlin. That's there in Micronaut 4. Speaking of Kotlin, and here I'm going to ask Graham to talk to you more about. We have now, when you go to Micronaut Launch or with the CLI, if you select Gradle, we are going to default to use KSP to power our Kotlin integration. And if you use Maven, we will default to KPT. And if you want to use KPT with Gradle, that's still possible. But actually, what's KSP, Graham?
Okay, so first of all, the way Micronaut works with all languages, it's essentially a compiler plugin, right? So for Java, it works via plugging in as an annotation processor. And within the context of the annotation process, we can see the source code AST and run all the compilation-related logic that makes Micronaut work in the context of the compiler. Now, historically, there was no official way to plug into the Kotlin compiler natively, right? So there was the only option was KAPT, which is essentially allows you to run Java annotation processes, but with a Kotlin compiler. Now, it has several disadvantages, KAPT, in that, or CAPT, or I'm not sure what the acronym is. But basically, one of them is that the way it works is it generates stubs. So it generates Java stubs from Kotlin code. And with those stubs, we lose a lot of the context of what the actual Kotlin syntax is, because there's not always equivalence in Java, in the Java stubs, to certain Kotlin constructs like name parameters and delegates and all sorts of things. The other issue with CAPT is that it's slower, because it has to generate the Java stubs in a separate step, and then we have to compile. So it's like a two-step compiler. So I believe it was Google that came up with, because they were, Android is heavily based on Kotlin, and Android is also heavily based on annotation processes and compiler plugins. So they were hitting all these same problems. So they came up with something called Kotlin symbol processing, which is KSP. And what it is essentially a replacement for CAPT, but it models the native Kotlin syntax in native AST, essentially. So in Micronaut 4, we have, now from a user perspective, users probably won't notice it, but we've essentially rewritten the compiler from the ground up. The compiler has been completely rewritten to allow us to plug in multiple language ASTs more easily, or in an easier fashion. So, previously we had Groovy support and Java support, but Kotlin support was kind of using the Java support by using the Java annotation processes. And now we have Groovy, Java, and Kotlin. So we have to model the different ASTs for the different languages, and that required a significant rewrite of the compiler, which is one of the reasons why this is, Micronaut 4's development cycle has been a bit longer. But the good news is now we can use KSP. It's not a perfect world because it's Gradle only, right? So there's no Maven support, but it's significantly faster. And a lot of the bugs that Kotlin users have historically complained about, which were related to us not being able to see the kind of native Kotlin syntax, have been fixed with KSP. So we can actually see when a name parameter is a name parameter, or when a delegate is a delegate. So with KSP, you'll get significantly, if you're a Kotlin user, you'll get significantly faster compilation times and a better experience, a better user experience. Incremental compilation still works, and as far as I understand, CAPT is also like in maintenance mode.
Yeah.
Where it may eventually be deprecated and removed in future. And the pathway forward is KSP. So KSP is the long-term solution, and that's why we're recommending it as like the default for new apps that use Gradle.
Yeah. So if you want to try it out, just go to Miconaut Launch. You will be able to download a milestone. So you will be able to download Miconaut 4 milestone 5, select Gradle, and by default, you will get a build using KSP. We encourage you to try it out. As Graham said, both still work. So KAPT or KSP, you can use both with Gradle, and with Maven, you will have to use KAPT. Speaking of Kotlin, we support Ktor 2 now in the Miconaut Kotlin module. We have integration with Ktor. So for those who don't know about Ktor, Ktor is a Kotlin framework, and you can use parts of Miconaut together with Ktor, for example, dependency injection. So if you were like using Ktor and Micronaut, you can update to Ktor 2 and keep enjoying the use of those Micronaut features. Another big thing in Micronaut 4 is we raised the baseline of Java 17. So Java 17, so Micronaut 3, which will still be supported, baseline is Java 8. So you can build you could already build an application with Java 17 using Micronaut 3, but since we had to support Java 8, we were constrained to use all of those features. We are comfortable raising the baseline because we have seen like the industry has moved to Java 17. All the major cloud vendors, they allow you to choose 17 as a runtime. Java 21 is around the corner also, and we will support that as well. But for Micronaut 4, the baseline is now 17, and one of the things that allows us is to use modern Java features. So we have been using modern Java features in the internal framework code, such as shield classes or things like that. But it has allowed us also to adopt features such as the built-in Java HTTP client, which was released in Java 11. So Micronaut has a wonderful HTTP client that you can use in any kind of application, even if you don't want to use other parts of the framework, which is based on Netty, and that's still around. And it's great because it essentially allows you to work in two ways. You can either work in a kind of low-level client, or what we typically call declarative HTTP clients, where you write an interface and the interface is implemented by the framework. So you just write an interface and forget about it. We have another implementation, so you can have the same code, and if you want to use the built-in Java HTTP client, you can essentially change one dependency and do that. We published actually a video in our YouTube channel that shows this in action. The Netty HTTP client is still more fully fledged. It supports more features. Actually, the Java, the implementation based on the Java HTTP client doesn't support certain features, such as I think HTTP client filters and I think proxies as well. So check the documentation. There are certain use cases that may not be possible, but one of the things that we have been talking about the framework is that we are kind of agnostic. You can select different runtimes, and now you can select also different HTTP client implementation. Anything you want to say about the Java 17 baseline raise, Graham?
Yeah, I think that I think we're going to cover virtual threads later, which is beyond Java 17. But I think the Java 17 baseline allows us to expose a better API in a lot of cases for more clearly delineating what's like extensible and what's not extensible with sealed classes and interfaces, and more extensively exposed like records, Java records. And hopefully also it means that one thing that was impacting is a lot of our tutorials and guides were essentially written in Java 8 style because we had to support the minimum common denominator, right? And so now we'll be able to write better guides that use more modern patterns, more modern Java syntax, guides that use records, etc., etc. So yeah, I think it's going to benefit our documentation a great deal in terms of being able to recommend the best practices of today, right?
Yeah, yesterday we published a video showing another feature that I will talk later called Object Storage Local, and I was using records, and we support records in not just like for POJOs in your project, but also like you can serialize records into JSON. You can use records for mapped entities. It is nice to be able to use modern Java in our documentation and our tutorials because the user experience, I think, it is shown there. Would be great to fix your Miconaut to use new pages, to use the new style. Yeah, we have to. So there is a question in the Q&A. Sorry for context for the people watching the video afterwards. So it would be great to fix your Miconaut sites to use the new pages. I don't know if you're talking about the YouTube channel or the. So we recently moved to a new YouTube channel, and there may be some broken links. So we are working on updating those. Thanks, Joseph. And yeah, that's the idea. Speaking about modern Java features, we have an initial support for Java virtual threads, which you can, if you are using a JDK with virtual threads enabled, which I think it will be enabled by default in Java 21. Is that correct, Graham?
Yeah, so basically when users upgrade, well, you can do it today now with JDK 19 if you enable preview mode, right? Because virtual threads are already available in JDK 19 and above. So you can add the enable preview flag to your application's parameters. And then what happens is if you either annotate any controller or controller method with execute on blocking, or I believe you can even configure universally to run all operations on blocking thread pool. Micronaut will essentially offload from the Netty event loop to virtual threads to perform any work, allowing you to write in a more imperative style. Now, in addition to that, we have been working on essentially optimizing the entire HTTP stack. So in Micronaut 4, the HTTP layer implementation for Netty has actually been also significantly rewritten and optimized to factor in the case where you are not using reactive programming. So we'll probably talk about it later, where we've got support for annotation-driven filters and new essential internals to the HTTP layer that mean that when you are not using reactive programming and you're using virtual threads, you don't have the reactive stack frames present in the stack trace, and we can optimize execution. And the net result of that is for Micronaut 4, we've seen up to 50% improvements in throughput, not necessarily related to virtual threads, but just in the overall optimization of the HTTP execution. So we're planning for a future where there are no effective reactive stack frames in the execution of your logic at all. In a world where virtual threads are the default and people are writing mainly imperative code, again instead of reactive code, or I think there's still going to be many use cases where you do want reactive, the ability to do reactive programming, because virtual threads don't support things like back pressure, but there's still going to be a lot of use cases where the default is just going to be to configure to use virtual threads, right, and write imperative code. So we're planning for that future, and this is available now, and you can try it out and test it out and use virtual threads today with Micronaut 4.
Yeah, so if you have used Miconaut for a while, you probably have seen this annotation, that execute an annotation, and you probably have seen it with the value of IO. And the idea here is, if you were like doing any logic that was blocking, you don't want to block if you were using also the Netty runtime, which is the default runtime, you don't want to block the Netty event loop. And with that annotation, you essentially tell it like execute the contents of this method in the IO thread pool. The blocking, and what we recommend you to do is when you upgrade your applications to Miconaut 4 is search for your execute on annotations and replace the IO with the blocking that you can see there in the slide. If you are using a JDK which still doesn't have virtual threads support, it will do the same as before. So it will use the IO thread pool. But when you upgrade to a JDK that has virtual thread support, it will automatically use virtual threads when available. So in terms of your code, our recommendation is just change your execute on annotations from IO to blocking, and you will be ready. More. GraalVM 23. And here, Graham, and ask you again for your help, because it's not just GraalVM 23,
Yeah.
the whole metadata repository.
So yeah, we've invested a lot in the last year in GraalVM and multiple layers of the framework. So obviously this release is ready for GraalVM 23, which just came out, and that goes without saying. But we've also been working on making the whole GraalVM experience even better in Miconaut 4. So part of that has been to completely alter the way we integrate with GraalVM. So in Micronaut 4, we are using completely runtime initialization instead of build time initialization. Now, for you guys as developers, maybe you didn't even notice this difference or understand this difference. But basically, Micronaut 3 used a combination of build time initialization. And that led to a number of issues, for example, where people would encounter things like log files being initialized at build time accidentally, or problems with the logback or log4j, or various other issues. And we had a number of GraalVM features that kind of extended and replaced and tried to adapt to that. But we've been working very closely with the GraalVM team. The folks contributing from the Oracle side to Micronaut in what should be the future. So for Micronaut 4, it's completely shifted to runtime initialization, and we've moved all of the metadata that was previously Micronaut specific into a shared metadata repository that we co-developed with the Spring engineers. So now Miconaut and Spring are sharing the same GraalVM metadata, and the whole community is sharing the same GraalVM metadata regardless of whether you're using Micronaut or Spring. That metadata is there. We on the Micronaut team also developed the official GraalVM Maven and Gradle plugins. So we are the ones responsible for building and developing the official plugins for Maven and Gradle for GraalVM, which are then consumed by Micronaut and consumed by the Spring team and consumed by other members of the community. So we have designed those plugins in a way that they use the shared metadata repository, and that has a profound impact on the whole community, right? So now we have this community maintained and tested repository of configurations, and we've set up an infrastructure that runs JUnit 5 based native tests on all of that metadata to make sure it works. So all of this is about making the entire Java ecosystem more compatible with native execution, right? Because previously with GraalVM, there was a lot of silos of compatibility, where you have to use either Micronaut, or you have to use either Quarkus, or you have to use either or specific configuration or whatever. And that's what we're trying to move away from, where native image should just work for all Java workloads with a set of, as long as you use the official Maven and Gradle plugins and the metadata is available, and it should just work, right, without developers having to get involved. So we've worked extremely hard to put in a vast suite of GraalVM native tests all across our infrastructure. Every Micronaut project has native JUnit 5 testing that runs all the tests natively, and an immense amount of work has gone into make this the most compatible, the most seamless experience that you can have with GraalVM native image in the Java ecosystem.
So one of the things for users, so you can use this already if you want in your project. So if you want to deploy to your Micronaut applications as a native executable build with GraalVM, if you go now and you select Micronaut 4, Milestone 5, and you select Java and JUnit, I think you have also, so you can run your test with tests, but we also have native test, I think is the name of the
write native JUnit 5 tests, yeah.
So that will essentially run you can run tests against your native image. So one of the issues is, or one of the worries is always will my application behave the same? And being able to test it against a native executable of your application is the way to go. So we use the same to test Micronaut, how it's built internally, and we recommend you to do that. So as I always said when they asked me about GraalVM and Micronaut is,
Yeah.
It's like a match made in heaven, and we continue to invest in that.
And also there's lots of things, lots of integrations that we've built that go beyond that, where we have Gradle VM in mind. So another example of that is, you mentioned native test, where you can do Gradle W native test, but we built integration with test resources and test containers that is compatible with native image. So you can do Gradle W native test or Maven test native. And if you're using test resources and test containers to spin up a MySQL database or any kind of database, it still works, right? So you can write native integration tests. And all of Micronaut's integrations, whether it be for Kafka, for Micronaut data, for all of our integrations are using this feature to test that we can natively run all of the official libraries, for client libraries, for all the database drivers and everything. So native testing, including with test resources and test containers, is something that we've been heavily focused on. And I don't think there's any other project in the Java ecosystem that has as much infrastructure for testing as we do. It really has been an immense effort.
So the test resources is a great point. So we have integration with many libraries. So things such as what Glenn was mentioning, like databases or messaging solutions as Kafka, but is extensible. So if your company uses any like third-party library, that chances are it's probably distributed as a Docker image, it's really easy to plug it into test resources, and test resources will give you like a separate class path separated from your application, so that you can test your native image without polluting the class path for things that you only need for your tests. So yeah, absolutely. Great experience as well. More things. We have moved to Gradle 8. So if you go to Micronaut Launch or to the CLI and you need a Micronaut 4 application, you will see that we use the Gradle 8 Micronaut 3 applications. We're building with Gradle 7. So yeah, it should not be any problem. If you are using Gradle and we have new versions of the Gradle plugin. So I think the version as of today is 4.0.0 milestone 6, and if you are using Gradle and Micronaut, you probably have also the shadow jar dependency there, so you will have to update that to 8.1.1. So it's an easy update, but I will talk more about how to upgrade at the end of the talk. But yeah, Gradle 8. Micronaut data supports Hibernate 6. And this gives me like an opportunity to talk about the end of the Jakarta transition, not just for microdata, but overall. So if you were working with Micronaut 3, you probably have a mix of JavaX and Jakarta imports in your class path. Now that's all done. So you will have, if you are using Jakarta persistence, you will have Jakarta persistence imports. If you have Micronaut email, you will use Jakarta email. If you were using injection, you were already using Jakarta.inject. And for validation also, you will be using, instead of JavaX constraints validation, you will be using Jakarta. So finally, and I think this finally works, it is Jakarta transition is over. So looking forward to stay with Jakarta imports for a long time. Do you want to say anything about the Hibernate 6 support or?
Yeah, no, I mean, there's a lot of this. I'll just add to what you said about the Jakarta. So there's been a lot of like background work to go into the Jakarta migration at the framework level as well. So one of the things, for example, what you mentioned, Jakarta validation, the new version of Micronaut 4 comes with Bean Validation 3 support, which is the latest Jakarta validation namespace. And that includes a shift to allow, for example, things like annotations on generic type arguments. So instead of, you can say list of, angled brackets at not blank string to, to actually define annotations on the generic type arguments to a list and have those validated and integrated with the framework. So, it wasn't just a case of, rename JavaX to Jakarta.
Yeah.
It was also a case of, okay, we've got to do this, but now we've got to support like the new things that come with those new specifications, right? So, exactly. And an important part of that was generic annotations on generic type arguments, which involved profound changes to the compiler and the way the whole framework works.
Yeah, that's a good reminder about the validation. Validation has a new home. So if you are using Micronaut validation, validation has moved it to its own modules. So go to docs.micronaut.io and you will find a link to Micronaut validation. It's essentially, you'll have to change the group ID. So it has a new group ID, io.micronaut.validation. And you will have to also add an annotation processor to your class path. We have all of that in a how to upgrade to Miconaut 4 blog post. So don't worry about it, but it has a new home. Serialization. So I think we released the Microcization in Micronaut 3.3, if my memory is good. And we released last week 3.9.4. So it has been several minor releases since we added Micronaut serialization. In Micronaut 3, by default, your application had a transitive dependency to Micronaut Jackson data bind. That's no longer the case in Micronaut 4. In Micronaut 4, if you want to render JSON, you have to choose which serialization flavor you want to use. If you go to Micronaut Launch, we default to Micronaut serialization. So that's the dependency on the top, the Micronaut ser the Jackson. Both are supported. We recommend you to use so Micronaut Jackson data bind is Micronaut Jackson data bind uses Jackson data bind behind the scenes. Micronaut Jackson data bind is great, but is a bigger scope than Microserialization. You can serialize anything. In Microserialization, you have to opt in to which things you have to serialize with the observable annotation.
Yeah, I think the new default. It's kind of like the difference between like Micronaut Data, JDBC, or JPA. Something like Jackson. It's basically Jackson is like a 2.5 megabyte jar file, and it includes significant runtime infrastructure that's based on reflection in order to allow all the features that Jackson supports. So when you use Jackson, it swells like your jar distribution and your native image by, I think it swells the native image by about 5-6 megabyte in size. And in general, Micronaut serialization also has a set of defaults that we believe are more secure. So it doesn't allow arbitrary serialization and deserialization of any type. You have to be explicit about what is actually serializable and what is deserializable, which helps you avoid vulnerabilities that may emerge from accidental deserialization. For example, if you have a type and you have like a field, you add a field that's like admin credentials and you didn't realize that thing got serialized to your JSON output or something like that, it would fail to serialize that type, right? And Micronaut serialization is like 85-90% compatible with all the different possible Jackson annotations that you might want to use. So it's pretty feature complete. And with Micronaut 4, we've also decoupled all the modules from Jackson. So we put significant work into decoupling the discovery module, all the GCP, or all the different modules that had like direct dependencies on Jackson. To so that you can essentially swap up the implementation and not notice, right?
We even have a type. We even have this API called JSON Mapper. So if you ever injected like an object mapper from Jackson, we have an equivalent called JSON Mapper, and you can essentially change the implementation and work in an API which is really similar to the API from object mapper from Jackson. And the point that Graham did earlier, so if you are hearing this thing and you are afraid that you're going to have to change a lot of your code, you don't, because most of the Jackson annotations are supported, so you can use the JSON property, all of those things. So it probably, the only thing that will require you to change is at a class level, you will have to opt in and say, this class I can serialize. And you can even go as granular and say, this class can be serializable, but it's not deserializable. So it's really, it sounds more complicated than it is to transition to use microcization. Anything else you want to say about microcization, Graham?
Yeah, I mean, and there's other aspects related to performance, because it's Miconaut serialization and Gradle VM integration. So Miconaut serialization is completely reflection-free. Underneath the service, it's using our introspection, so it's able to write objects to JSON and read them from JSON without using any reflection whatsoever. So that's both more performant and easier if you're considering Gradle VM native image. With the Jackson, we make our best effort to correctly configure the types so that they work with Gradle VM native image, but ultimately Jackson is using reflection underneath, right? So all that reflection data is required in order for it to operate and do what it does. Right?
Yeah, that's a good point. Microcization is reflection-free, as are almost every part of the framework. Next is another feature that I think is exciting because it's kind of a user-facing feature, is expression language. I have here in the slides one example where we integrate expressions with Miconaut security and the add secured annotation. Can you talk about what the expression language support means for the framework?
Yeah, absolutely. So, I was at the beginning quite reticent or quite cautious about adding an expression language to Micronaut because it's, there's been several historical vulnerabilities in frameworks that have expression languages. And, I wanted to do it in a kind of, if we're going to do it, we're going to do it the right way. So it's taken a long time to define what it is that we wanted out of expression language. Fundamentally, what it lets you do is put expressions in annotations. So in this example, in this slide, you can see that we're securing a method using add secured, using an expression that checks a user's email address. And the expression that you can place in there is very similar to it has some things from Groovy, like the safety reference operator, but it's basically a little language where you can essentially refer to a current context and so forth. Now, the big difference with Miconaut expression language is it's completely compilation time. So whatever you put in that expression is type checked, compile time checked. If you make any syntactical errors in the definition of the expression, you'll get a compilation error at compile time. And telling you exactly what is wrong with the expression that you defined. It's also completely reflection-free, so there's no reflection in the execution of the expression itself, so it's automatically native image compatible out of the box. And it's also not possible to, at runtime, compile expressions. All expressions are compiled and computed by the compiler during compilation time. So all the potential vulnerabilities that could be exposed by runtime evaluating expressions that exist in other frameworks don't exist in Micronaut. It's impossible to, at runtime, compile an expression dynamically from user input. So it's completely safe, secure, and provides a lot of flexibility. So this is an example of X secured, but we have other examples of doing conditional job scheduling, conditional routing, and I'm quite excited to see how libraries and modules in the ecosystem of Micronaut adopt expressions and use it for different cases. I think there's more things that we can do, for example, conditional caching in the cache module. There's loads of more potential things that will be interesting in the coming minor releases in the next year.
Yeah, I think it opens a possibility for cool features. One point is that I want to make is extensible. So the example that we have here is using that extensibility. So the core support for expression language is in the core of the framework, but you can essentially contribute to the expression language context in your own applications. So if you want to write whatever you need for your special use case, you will be able to essentially leverage this to your advantage or to your use case. More things. cloud environment detection off. So this is something that I want to warn people about is, so we have this feature called cloud environment detection. The idea behind is, so we have this concept of environments, right, in Miconaut, which allows you, for example, the typical thing that I use with environments is you may want to have a configuration file that is only loaded when the application runs with a particular environment. So imagine you have an application-production.yaml or application-production.properties, and you want to load that configuration file only when you run your application in the production environment. So we had this feature in Miconaut that when you took a Miconaut application and you deploy it to Oracle Cloud, to Amazon Web Services, to Azure Cloud, to GCP, it will essentially do some checks. So it will search for files in the operating system or environment variables that were available, or even do network requests to essentially check where it was being deployed, and it was essentially configured itself. So it will say, okay, I am being deployed to an EC2 machine, so I'm going to add the EC2 environment and the cloud. And I think at the time it looks like a nice feature, but the problem is you are paying that cost of essentially doing all those checks every time you run the app, and probably you run the app millions of times during development and testing, and it doesn't make any sense that you are paying that cost by default. So what we have done in Miconaut 4 is we have turned it off. So my recommendation is, you can turn it on if you want, but my recommendation is if you have like an application does EC2 or an application does GCP.yaml file, you can also configure the Miconaut environments using, for example, the Miconaut environments property environment variable. So you can take control and make sure that when you deploy, those environments are present. So just a warning that this thing is off. So if you rely on a certain environment to be present when you go to the cloud and you were like getting that environment automatically, just remember that you saw this presentation and that you have to either turn it on or controlling with the environment variables or system properties that we give you to control the Miconaut environments. Do you want to say anything about this, Graham?
No, I think you covered it. Good.
So the next thing I want to talk about is Sebless. We have done a lot of effort. So we have different runtimes. We always say like Miconaut is runtime agnostic. We support Netty, Yeti, Undertow, Tomcat, but we support also AWS Lambda, Azure Functions, Google Cloud Functions, or Google HTTP Functions, and
Oracle Function as well.
And Oracle Functions as well. And we have a server TCK. We have a test compatibility kit, which we wrote in Miconaut 3, which essentially allows us to write to essentially test that. What we always tell you is you can take a Miconaut application written with controllers and deploy it to the cloud, and when you deploy it, the application should behave the same, right? It should work if you have these controllers with these annotations, whether you are going to Netty or you are going to Azure or you are going to Lambda, it should behave the same. And we have done a lot of effort so that all of our serverless runtimes, they are TCK compliant. And they are, and not just that, but also the test components that they have so that you can run your applications locally. They are also TCK compliant. And for example, in AWS Lambda, we have gone even further and we have decoupled the function supports for the Sebless container library. Now we depend on the AWS Lambda events library, and we have built-in handlers for things such as Amazon API Gateway Payload V1, Amazon API Gateway Payload V2, and also application load balancers. So yeah, now it's really easy to essentially deploy a Miconaut application to Lambda and be essentially called with any event that you want us to support. So yeah, more robust support for Sebless in Miconaut 4. Annotation-based HTTP filters. This is another feature that is part of Miconaut 4. So we support server filters and client filters in Miconaut 3. And when you were writing a server filter in Miconaut 4, in Miconaut 3, sorry, you will implement the interface HTTP server filter, and that will essentially force you to override a method which publish and return type. And what we have seen is that many users, they don't want to write reactive code. So they want to write all their applications. This is related also to what Ryan was saying earlier when we were talking about virtual threads. They want to write always using imperative codes, and sometimes they just want to create a filter to do something that requires actually no reactive code, because maybe they just want to log some HTTP headers, or they just want to add like an extra HTTP header to the response. That's the one being shown here. And in Miconaut 4, we support this alternative way of writing filters, which is annotation-based. So you see here that I have a couple of methods. One is annotated with add_request_filter, and the other one is annotated with add_response_filter. You see that you can use it in combination with add_execute_on. If you are like blocking, you can offload. Yeah, this is another alternative. I think many people are going to like this new approach to write filters. For simple filters, this is going to be probably the way to go for many users. And looking forward for you to try it out and give us feedback. Is there anything you want to talk about annotation-based HTTP filters, then?
No, I think we've you mainly covered it. I think, like I said, it's looking ahead, planning with regards to virtual thread support and so forth. So it's all related. We have added some niceties, because there's you can define these request filter and response filter methods, which take a certain set of arguments, possible arguments. And we've integrated that all with like compile time checking in the framework. So it'll like tell you if you define an argument that's not supported and so forth, which is really nice. Once again, the framework giving you guidance of like what's possible whilst the application is compiling, which is cool.
Yeah. So I will explain this slide in a second. So what we have in the top of the slide is what we supported in Miconaut 3, which is you have code, right? And we will essentially you will use the Miconaut OpenAPI module, and we will generate at compilation time, we will generate an OpenAPI specification of your application. So you have your application with classes annotated with that controller, and at compilation, we were generating this OpenAPI document in your class path. So you can try this. You add the annotation processor Miconaut OpenAPI, you run compile Java, and you will see like this OpenAPI YAML file appear in your build folder. And what we support in Miconaut 4 is we still support, of course, going from code to OpenAPI. But what we are adding to our build plugins is to go from OpenAPI code, from OpenAPI specification to code in your project. And this will essentially allow you to essentially what we will generate. We generate currently like an abstract controller.
Yeah, so we generate an interface, in fact, with the API definition, and we'll generate all the model classes that you would need to serialize and deserialize from the API specification document, basically.
So if you want to like, your team is give you like this contract. This is the API that you have to build with OpenAPI. This is gonna give you like a really nice head start to start writing your application. And also we support also like for generating HTTP clients, which I think is going to be used a lot, right?
Yeah, definitely.
So if you want to consume an API and the documentation that they give is an open API, you're going to be able to generate that really simple.
Yeah.
So really cool. Open API, I think, is one of the most impressive things about the framework is like you write your application and you hit compile and the specification appears. And that's always something that I am really happy to see. We support in Miconaut for Microstream 8. So we supported Microstream 7. We support Microstream 8. We also support several storage targets for Microstream in Miconaut 4. We support S3 PostgreSQL and DynamoDB. We are actually collaborating with the people from HyphenQ. HyphenQ is also a sponsor of the Miconaut Foundation. They are contributing an implementation of, so we already have a HyphenQ module in Micronaut, and it was using Eclipse Paho, I think it's pronounced. And now we're going to have another implementation based on the HyphenQ and QTT client. So if you are working with MQTT, you may be using HyphenQ, and this is going to be essentially make your life a little bit easier. And it's really nice to see like companies contributing to the framework. Object storage local. I published yesterday a video in YouTube about that. So for those who never heard about object storage is our module that simplifies you to work with Amazon S3, Oracle Cloud Infrastructure, object storage, I think it's called, Azure storage, and Google storage as well. So all the solutions that the cloud vendors offer to essentially save like an image or a PDF. We give you like a cloud agnostic API that you can, and it's not just we give you like a cloud agnostic API, it's like we do most of the heavy lifting for you. So if you want to save typically in the cloud, you just specify the name of the bucket or the object storage container that the cloud gives you, and off you go. And object storage local, as you can imagine, is the same idea, but to save to this. So if you are, this will be especially useful when you are like developing locally, or you want to test your application with the same code that you typically use to save to the cloud. While you local develop, you can save, like you can test, like you can upload a file and save it in your hard disk. So a really nice addition. We have a new module called, do you want to say anything about object storage local? Sorry, Graham.
No, I think it's you covered it. It's going to be useful for testing, so you can maintain your application being cloud agnostic. Yeah, it's good stuff.
And another one that we have that is going to be especially useful for especially for development is called Micronaut Control Panel. This is going to give you like a UI. This is a new module that we already released, like a milestone. And this is going to give you like a UI that you can essentially use to visualize. I think it has integration with the management endpoints. And I think we are also working in integrating, I think the jobs schedules. Maybe I'm mistaken, but yeah, this is another addition that we have. It's kind of a web UI that you're going to be using when development. A new module, another reason to upgrade to Miconaut 4. What else do we have? We have integration also in the GraphQL. We have support for the new WebSocket protocol as well. So GraphQL is another module that we want to keep investing in. And yeah, if you are using Miconaut GraphQL, check it out. And we have many more features throughout the framework, so I'm probably forgetting a lot of them. Is there anything else you would like to plug, Ryan?
No, I mean, I think you covered a lot. I think there's lots of little quality of life improvements that probably are difficult to cover in the context of this. We've really improved like error messages, so that when if a bean is like disabled, and you get a no such bean exception, if it was disabled because of like some missing configuration or missing requirements, we actually unwrap the error and make it more understandable why the bean was not present, right? So you get no such bean because you're missing this configuration. So we had lots of reports of like people saying, hey, Micronaut data is not working, and it was because they had an extra space in their, YAML definition or something like that.
Yeah.
In the YAML indentation. So hopefully this will help like solve some of those problems. I mean, speaking of YAML, we also like YAML is now optional, I think, so as well. Correct. In the framework in Miconaut 4. And we've also like improved error messages for a bunch of other use cases as well.
this is a feature that I just wanted to show because I think it's pretty interesting. So, and I think you wrote this feature.
Yeah.
We support the injection of maps. So imagine you have this example where you have like an interface called importer, and you may have like two implementation, one for importing a CSV file and another one for importing an Excel file, right? So now in Micronaut 4, you can go in your controller and say, inject me a map where the key will be the name qualifier of the bin, and the value will be the bin. So in this case, like a CSV or the Excel importer. And I know this is a silly example that I put together, but the idea is like based on the file extension of the thing that you are uploading, you are going to be able to select the bin that you want to choose. So if you ever found yourself in a use case where you wanting to inject a map of a bin name qualifier and the bin, that's possible in Micronaut 4. I think this will give a compilation error in Micronaut 3, if I remember. So yeah, this is another cool feature that I forgot to talk about, but now that
injection of maps is pretty nice. We also solved like arbitrary nesting of configuration properties in each property, so that you can have like nested structures. And previously we could have like nested configuration properties, but if you had like an each property and nested within each property, it kind of didn't really work properly. And we fixed all of that. And there's lots of like quality of life improvements. Like I said, like in the management endpoints, you can now go in into the beans endpoint and see which beans were disabled by configuration and why they were disabled. So yeah, lots of little stuff.
Yeah. So we don't have a lot of time for questions because we ran a little bit. There is a question from Michael. How will the Micronaut integration, the Microstream 8.0 integration now that... So let me read the question. How will the migration of Microstream 8 to the Eclipse Foundation affect Micronaut? So Microstream is going to be called the Eclipse Store, and they are going to essentially Eclipse Store. The first version is going to be Microstream 7, and the next one is going to be Microstream 8.1. So what we'll probably do once they have the Eclipse Store goes to Microstream 8, I think what we will do is we'll probably create a new module. It's going to be mostly a package rename. So the whole packages of Microstream are going to change. So it'll probably be like another coordinate for Micronaut users. But yeah, it will essentially be supported because Eclipse Store is going to be essentially be Microstream 8. So yeah, I don't anticipate any. You will probably have to add a new module, but essentially the functionality will be the same. I don't know exactly how the transition of data is going to be. So that's probably a question more for the Microstream people. If you have like a Microstream per system, if you are going to be able to transition to Eclipse Store, that's probably something that they will have to answer. But yeah, essentially, we are aware of the Eclipse Store transition, and we'll work with them. Let me see if there are any other questions. There was a question about server-side filters that I answered about that they like the way they look. About the Open API generator, yeah, we are going to add documentation to the Gradle, to the build plugins, basically, because this is going to be mostly supported through the build plugins, and we will actually... So we had two guides about Open API generator using... So we already contributed to the Open API. I have like a component to generate like code from a specification, and we already had like contributed to Andrew, one of the members of the Miconaut core team contributed that, and we already had guides. So what we will do is we will update those tutorials to use the new built-in generation. And there is another question. Will you share the presentation slides together with the recording? Yeah, we'll probably publish like a blog post with the recording. The recording will publish to our YouTube channel, and the slides will be linked in the blog post as well. Paolo, are there any other questions? No questions. So yeah, really excited about the release of Micronaut 4. Thanks a lot, everyone, for taking the time to join us today. Thanks, Graham, for joining me. Yeah, looking forward for everyone to test Micronaut 4. Please try it out if you are able to try it out in your projects. Last one thing before we wrap up. So we have, if you want to try it out in your applications, let me show you a link. So if you go to micro.io, the home of Micronaut, micronaut.io, and you go here to our blog, and you click here on Micronaut 4, you will see upgrade to Micronaut 4. We are working with the people from OpenRewrite to give you like an integration with OpenRewrite. In fact, we have a webinar next week, which I think is we have a webinar which shows you how to update a Micronaut 3 application to Micronaut 4 really easily on July 6th. So that's next week. Again, a free webinar similar to what we did today. So if you are able to join us next week, please do. If you can't wait, and I understand, we have this blog post which will detail the steps that you have to do manually to update your application to Micronaut 4. And we have also actually written several blog posts about how to update to Micronaut 4. And also we have in the YouTube channel, we have like a playlist called Micronaut 4, which should have some of the videos about the things that myself and Graham talked today. And we will be adding more. So please check the blog post about how to update to Micronaut 4, check the YouTube channel, and check the documentation in every module about what changes, what's new, what's the breaking changes, the thing that we're deprecating and we have removed. So read the docs. We are putting a lot of effort to have them up to date. And yeah, again, thanks for watching and see you soon.
Thanks, guys. Appreciate your time today.
Bye.
Take care.
Bye-bye. I'm gonna pause the recording.